Okay, hey everyone, this is Jake. I'm going to do a review going over amino acids, peptide sequences, and beta turns and alpha helices. Okay, so let's jump into it. First and foremost, you need to be able to have all of your amino acids memorized. Okay, so that means that you should be able to draw the basic structure of an amino acid like this, and you should be able to fill in the side chain. Okay, where the only one that doesn't have a side chain, as you can see here, is glycine. It's just two hydrogens there. Okay. So let's look at the basic structure of an amino acid. Okay. So an amino acid is going to have an amine group and a carboxylic acid. But proteins and amino acids exist in your physiological pH, where they will be protonated and deprotonated according to that pH of 7.2 and their relative Ka. So as you can see here, there is an N terminus, and that N terminus refers to the ammonium side, and then there is a C terminus, and that refers to the carboxylate side. So that's how I remember it. So the N terminus has the nitrogen, and the C terminus has the carbonyl. Okay, so that's part one of amino acids. So from there, you should be able to draw, from this structure, you should be able to draw all of your amino acids, okay? What you also need to understand with your amino acids is, one, you need to understand which one is essential or not, okay? So all these with the stars here are essential. You should be able to group them in their categories. You might think this is very challenging, but once you have them memorized, it's actually not as hard as you might think, because something that is all carbon is going to fear water, be hydrophobic, okay? Something that is in a ring is going to be your ring and not many nitrogens or hydrogens, it'll be your aromatic ones, your hydrophobic and aromatic, okay? The reason why these ones are in a ring but not hydrophobic is because there's enough hydrogen bonding regions on here to engage well with water. Okay. Polar just means hydrophilic. Oops. Okay. So there's a hydrogen bonding region, hydrogen bonding region, hydrogen bonding, hydrogen bonding. Charged are all those that have a side chain that have a positive or negative charge on it. Okay. So once we start creating peptides and subsequent beta sheets, we're going to start building them based on what the purpose of these amino acids are going to be. For example, you might have something like this where water is over here and the air is over here, and you want this side of to be hydrophobic and the other side to be hydrophilic, or vice versa. I don't really. So this is water, and then this is something else, right? You can start building these peptides to have different properties, okay? So let's go back to Zoom here. Okay, the next part of this review, we're going to start putting the amino acids together, okay? So you're going to follow this pattern of linking them together, and they are linked in what we call, so actually let's talk a little bit more about amino acids, okay? You only need to know the one letter code. So for example, D, E, K, R, okay? So all you need to know is the one letter code and how to draw it. And then from there, how to draw. Additionally, amino acids are going to be linked together via peptide bonds. So these peptide bonds is just a fancy word for amide bonds. So we'll draw a little example here. As you can see, we'll cut this off here. These are two amino acids, and those are linked with a amide bond. Something that can confuse students is that once these two ends come together, it condenses into a polymer, and it's now in amide linkage. Okay, so you are not going to protonate this and deprotonate it based on the ammonium, what you would previously do up here. It is now just going to be a secondary amide, right? Okay, so the pattern to link them together is the N terminus is still going to be the ammonium, and then you just have this repeating chain of up and down amino acids. Okay, and I'm doing this pretty quick because I've had some practice. Okay, and then the last one is going to be the carboxylate. So as you can see, all of these have a carbonyl and a nitrogen. So this is one amino acid. This is another amino acid. This is another amino acid. This is another one. And this is the first one. Okay, and from this sequence, it's 1, 2, 3, 4, 5. So this is a very simple peptide that I just made up. The left one is going to be your N terminus, and this right one is going to be the C terminus. Okay, so let's build it together. All of your amino acids, S configuration at the stereocenter, except for cysteine. That one's going to be R, and I'll put a little star there. You don't do anything different. It's just because of a nomenclature issue where that oxygen ruins it doesn't change any way that you draw it. Okay, I want you to remember that. Okay, so if you draw it from N terminus to C terminus over here, and you don't need to include these, but I do it for this teaching purpose. If you're drawing it from left to right, if your amino acid is going down, it'll always be dashed. And the ones going up are always going to be wedged. Okay, that's only true if it's from left to right. Okay. And I'm drawing these amino acids from memory. And this is how you should be able to do this as well. Okay. Okay, so that is my peptide, where we have valine, leucine, isoleucine. You don't know these names. You can just say I, V, and alanine, A. Okay. So that is a peptide. Okay, and you can draw them left, but if you do it right to left, it'll just be backwards. So then it'll be wedged down and dashed up. Okay. So our next goal is to learn how they form terms. Okay. So let's draw. Let me get an example from my. Let me get an example from my notes here. Let's do A. Oops, that's V. A, V, G, P, C, G, okay? And the beta turn, this is a secondary structure, is going to be defined by the G and P, okay? So that'll always be given to you, okay? So this one is going to be what's around that beta turn, but the hydrogen bonding that's actually holding it together is going to be 2, okay? And I'll show you. So that's your N terminus and your C terminus, okay? So let's just draw, all I'm gonna do is draw the backbone. And this is what you need to have memorized. You need to be able to do the backbone of an amino acid because it'll help you always get it right, okay? So you're just going to start at your N terminus. Oops. I'll talk about this in a second. Okay, so we're going to have 1, 2, 3, 4, 5, 6, okay? What is unique about this is that you are used to alternating from dashed to wedged, dashed, wedged, dashed, wedged, okay? But there are going to be 4, 1, 2, 3, 4 that are all the same going out of the beta turn, okay? That's just standard, okay? A beta turn, by definition, is going to be a 10-membered turn, okay? And we'll count that together, mediated by this hydrogen bond there, okay? So if you're watching this, I want you to count very specifically. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The only hydrogen that we count is the one that is part of this hydrogen bond. I'll do that one more time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, where there's hydrogen bonding mediating between the 1 and the 10. Okay? And then if you do that, there throughout the rest of this beta turn, if it's much longer, you'll see that the hydrogen bonding regions line up. Okay? The next thing you're going to do is you're going to fill in everything. So we have A amino acid here, which we already have A. Then we have V, so valine. And then we have glycine, okay? So glycine actually doesn't have anything. Proline. Proline is going to be a ring, okay? And because of that, we get rid of the hydrogen. Okay, so that's proline. That's a kind of ugly one. Cysteine. And another glycine. So we get rid of that. Okay. So this is your beta turn. Okay. You should have this memorized. Or in fact, just this piece here. Being able to do that will immensely help you as you draw beta turns. Okay. Okay, let's continue with this. Let's do another one. Okay, I'm going to give you a peptide, and it's going to be, let's do Let's do a little bit of longer one. Let's do. I just like I just have a couple amino acids memorized, so let's just do isoleucine, cysteine, valine, isoleucine. Okay, where the beta turn is between the G and the P, or is on the G and P of that. Okay, and it's mitigated by this bond. Why am I drawing this? It's because the hydrogen bonding is the CO bond on valine and the NH on cysteine here. So it's these two that are mediating this. These guys are just the ones that are actually getting bent, okay? So let's do this here. This is called, this is the Jake trick. Okay? So if you have an even number preceding the two that are on the beta turn, and this isn't what Dr. Savage teaches, it's just a way that helps me always get beta turns right. If you have an even number preceding the two that are going to be around the turn, you're going to start your first amino acid down, so dashed like this, okay? If you do that, you'll always end up in this down beta turn like this, okay? If you want to memorize this and kind of use that as like a template, then if you have an odd number preceding the beta turn, you're going to start the first one up, okay? And I'll show you that. You ask why, and the answer is because it'll help us have the same format of the beta turn around here. That's not really chemistry, it's just a good way that I do it, okay? So we'll just draw my pattern. So that was isoleucine. This one is cysteine. Remember, is wedged. Okay, now I'm on valine. Okay, so that means the carbonyl on valine, this guy is going to be the one that does the hydrogen bonding with isoleucine later. Okay, so these two. Okay, so now I'm going to do my pattern, my 10-membered ring. So 1, 2, and this is just memorized. As you can see, just nicely. Okay. Okay. Now let's fill in. So we got isoleucine here. We have cysteine. We have valine. We have G, glycine. We have proline again. We have isoleucine again. We have alanine there. Okay. You might ask, you might say, this one is going down. Why is it not wedged? You have to imagine that we stretch. This is just a continuous chain. So if this end were to stretch out over here, this would be going up, okay? And remember, it's only dashed down if it's N on the left and C on the right. When we bend it, now the C is over here and the N terminus is over here. So we have to flip our rules, okay? One thing about this that I'm going to know is that you have two cysteines that line up with each other. Those undergo an oxidation reaction. Two cysteines actually really help hold that beta sheet together, okay? So this should be a good, pretty comprehensive overview of beta turns and amino acids, okay? I'm gonna move alpha helices to probably my quiz review, another video. They're not very hard, okay? So please reach out to me or another TA if you have any questions.